Alright, this is, excuse me, lesson 15 for 8th grade, and today we're talking about powers and roots, and we're going to find out that powers and roots are actually inverse operations, which we've been talking about before with adding, subtracting our inverses, and multiplying, dividing our inverses. We're going to talk about powers first, and then we're going to get into roots and see how they kind of relate. So, here we go. Powers, also known as exponents, are what we're talking about here. And this is basically, powers and exponents are used to show repeated multiplication. So we have a base here. We would say the base is 5. Our exponent is the small number that's raised here. Now this actually means that we're going to multiply 5 together twice. So this little number here, the exponent or the power, tells us how many times we're going to multiply 5 together. So if we look at this, we have 5 to the third power. That means 5 times 5 times 5, and we get 125. So once again, 5 times 5 times 5, because we have 5 to the third power. Or, one other way to read these, if we have, like this one, this was 5 to the second power, that's one way to say it. Another way to say it is 5 squared. You'll hear me say that quite a bit. 5 squared, 5 to the second power means the same thing. 5 to the third power also is the same as 5 cubed. Okay? Anything else, anything 4 or above to that power, we say to the nth. And that would mean, let's say we had 5 to the fourth power here, we would say 5 to the fourth power, or just 5 to the fourth. So you'll hear me use a lot of that terminology. 5 to the fourth saves on time. Don't have to say 5 to the fourth power every time. And to save on time, I might say 5 squared or 5 cubed instead of 5 to the third or 5 to the second. But that's all stuff that we can use. And remember, anything 4 or above would be 5 to the fourth, 5 to the fifth, 2 to the sixth, that type of thing. Alright, so that's just terminology there. Now, if we look at 3 to the fourth power, which we will solve in a second here, by definition, this means we're going to multiply 3 together 4 times. So 3 times 3 times 3 times 3. The common misconception, or the common mistake, is to take 3 times 4. This does not mean 3 times 4. So let's look at why these two are very different processes. Okay? This means we're multiplying 4 3's together. 3 times 3 times 3 times 3. Now, what does 3 times 4 actually mean? Well, we know that it's 12. 3 times 4 is 12. But what does it actually mean? Well, sometimes we overlook what multiplication actually is. But 3 times 4 means we're actually taking 3 plus 3 plus 3 plus 3. Okay? So we're actually adding 4 3's there. So the big difference between multiplying 3 times 4 and taking 3 to the fourth power is that here we're adding 4 3's and here we're multiplying 4 3's. So very different, and we will not get anything close if we try to do 3 times 4 here. It's definitely not going to be close to the answer we get here. And our next slide, we're going to see what that is. We're actually going to figure out what 3 to the fourth is. Simplify means we're going to put this in the simplest terms. Well, we know that it means 3 times 3 times 3 times 3. Okay? Now, a lot of my students want to grab a calculator as soon as they can. That's fine. You know, you can type that into your calculator. But if we know our math facts, this is a much faster process. What's 3 times 3? Well, we know that's 9. So 3 times 3 is also 9. Now multiply those two together. 9 times 9, 81. So we should be getting number 3 there. Mr. Smiley Face says, yeah, that looks good. So 81 there, okay? Okay, now we've got simplify 10 to the fifth power. Now that actually means 10 times 10, times 10, times 10, times 10, 5 times. This one actually has a shortcut. This 5 tells us how many zeros we're going to have behind our 1. So, which one of these has 5 zeros? Well, 1, 2, 3, 4, 5. Should be 100,000 there. Number 3. Smiley face agrees. Alright. So that's the shortcut there when you go by tens. And we're going to see this type of thing in the future with scientific notation. That 5 is actually going to tell us how many spots our decimal place moves over. So yeah, we'll get into that in a little bit. Okay. Now, prime factorizations with exponents. Let's take a look at the number 72 here. We've done prime factorization before. 72. Remember, when we look for the prime factors of a number, we look at what goes into it. So 2 factors that go into 72 are 9 and 8. Now we want to break these down because these aren't prime yet. 9 is 3 times 3. 3 and 3 are both prime, so we're done there. 8. 2 times 4. 2 is prime, so we're done there. 4 is not prime, but that breaks down into 2 and 2. Alright, now we have 2 3s and 3 2s. Now we're going to start with our lowest number, our lowest prime number that we have, which happens to be 2. So this is 2, and 2 times 2 times 2 is to the 3rd power, times, however many 3's we got, 3 times 3, 3 to the 2nd power. So remember, you always want to start with the smallest base that you have and work your way up. So 2, 3, if there would have been a 5, it would have had times 5 to something after that. Okay? So that's how we write a number in prime factorization with exponents. Okay. Now, this one, the students kind of freaked out a little bit about as soon as they saw it in class, but then they looked at their choices here, and it wasn't so bad, okay? We have, this is what this statement means. 3 times x times x times x times x times y times z times z times z. All of that's being multiplied together. Well, let's think about what our exponents mean here. Remember, if we had 3 times 3 times 3, that's 3 to the 3rd power. Well, let's pretend that these are numbers. They are variables, but if they were numbers, this would be 1, 2, 3, 4, x to the 4th power, whatever that number would be. So we have 4 x's, 4 of those, 2 y's, and 3 z's. So we want to look for the one that says 3x to the 4th, y to the 2nd, z to the 3rd. Okay? So number 2 should be what we're looking for there. Because no matter what those variables are, we know that it'll be raised to the 4th. I could put a 2 in there, I could put a 3 in there. You know, it wouldn't matter. So that's what we're looking for with one of those. Okay, now as I said before, we were talking about powers and exponents. Now we're going to talk about the inverse of that, or the opposite operation. That would be roots. And we've seen these before a little bit. One thing that this is called a radical sign. It's also a square root sign. Or if it has a 3 here, it would be the cube root sign. And you can put any number here. It could be the 5th root, or the 6th root, or the 107th root, depending on what number's here. Now, what does this actually mean? We would say the square root of 25 is 5. But also, the cube root of 125 is 5. Now, the explanation behind that is right here. So the small 3, what I was talking about before, that's the index of the root. The index, if the index is 4 or more, we say the nth root. So 4th root, 5th root. This one happens to be 5th root. Okay? Now, here's what it actually means. We're going to look for one number to multiply together 5 times in order to get 32. So we say the fifth root of 32 is 2 because if we multiply 5 2's together, we get 32. So it's kind of going backwards. So this would be 2 to the fifth equals 32. So the fifth root of 32 would just be a single 2. So if we look at 25 and the square root here, notice that this doesn't have a number by it, where this one does. If you don't see a number here, there's actually a 2 here. Okay? If there's not a symbol or a number there, it always means square root. Okay? So we're looking for 2 numbers we multiply to get 25 there. I'm going to check my time quick. We're doing okay? Alright? So this means what we would look for, square root of 25 is actually saying what squared will get us to 25. Oh, maybe not this. So what do we square to get 25? That will be the answer to the square root of 25. This one says, what do we take to the third power in order to get 125? So whatever we put in these boxes, that's going to be our solution to these. And I'll show you what that's like a little bit here. Alright, so if we simplify 144, this is the square root, so we're looking for 2 numbers, so what do I square in order to get 144? Well, I've been taking math for a long time. I know that 12 times 12 gives us 44. So this is, since 12 times 12 equals 144, the square root of 144 equals 12. Okay? This one, the cubed root of 27. Now we're looking for 3 numbers that we multiply, or 1 number we multiply together 3 times to get 27. So we're looking for what do we cube to get 27? Well, 3 times 3 times 3 equals 27. So the cubed root of 27 is 3. That's how we go about doing those. Okay? And I'm going to show you one more thing here. We're going to skip through this one, and we're going to get to this one. I want to check my time quick. One more time, got about 2 minutes left. Alright, a perfect square. We say a number that is a square of a counting number is a perfect square. Okay, so for example, 25 is a perfect square because 5 to the second is 25. So if we look at this one, name the first 3 counting numbers that are perfect squares, and then find their square roots. I'm not going to find the square roots, but we just take our counting numbers here. 1, 2, 3, 4, 5, 6, 7, 8, and we'll put 9 there. 9's a little hard to see. Which one of these are perfect squares? Is 1? Yes, because 1 times 1, or 1 squared, gives us 1. 2 is not. 3 is not. 4 is, because that is 2 to the second. The next one is actually going to be 9. 3 to the second. So, if we kept going, we'd see that 16 would be our next one, because the square root of 16 is 4. And then we get 25 after that. Square root of that is 5. So that's kind of what we're talking about today. Alright, we might have some more practice on this tomorrow. Otherwise, we'll start with lesson 16 soon. Thanks.